So our learning objectives today are identifying linear, nonlinear functions. Identify, interpret intercepts of function. What's an intercept? X-intercept, Y-intercept, where it does what? Crosses either the X or Y axis, right? Linear functions can be written in the form, your first blank spot is y equals mx plus b. Right, that's the equation of the line. What's the m? M is the slope and the b is, what's the y? Just a y. No, it's just a y. Right, so if we have an ordered pair like -1, 2, right, you had some of those on your summer packet quiz. The 1 would be the x and the 2 would be the y, right? Because we had equations where it's like had to be parallel and go through that point, right? That kind of thing. Linear functions can also be written in this form: ax plus by equals c. Okay? The key to that form is that a, b, and c have to be integers. So that begs the question, what is an integer? Anyone know? This is something you should really know by now, what an integer is. Not to make you feel bad or anything, but you should know it for sure. You learned in Algebra 1, probably 8th, 7th grade math as well. Right? Does anyone get irritated in math class? You seem like you're learning similar things year after year. Right? Geometry is different though, and then Algebra 2 is back to algebra. And then pre-calc is trigonometry, so like hardcore geometry, and then like even more hardcore algebra. It's like crazy pants, the stuff you do in there. Integer is like negative numbers, 0, and positive numbers. Okay, negative numbers, 0, and positive numbers. No decimals or fractions. So if it were me, I would write no decimals and fractions next to integers. And if you should all know y equals mx plus b. I mean, my God. You started doing that in 7th grade, graphing lines, right? And this is standard form for a linear equation. Why did I put FC? What's that mean? Flashcard, right? Flashcard moment. If you don't need y equals mx plus b, don't make a flashcard. That'd be dumb, right? If you already know it. But if you don't remember ax plus by equals c, it's good to make a flashcard. The slope, when you have ax plus by equals c, shortcut, negative a over b. That's how you can get the slope, just from an equation in standard form. So this one right here is called, I kind of don't have room. I'll draw an arrow up. It's standard form of a linear equation. There are standard forms for every kind of equation. So standard form means very little, but this one's of a linear equation. So in a linear function, so we're reading this bullet right here. In a linear function, no variable is raised greater to a power or to a power other than 1. So if it helps you to understand to put little ones right here, put little ones right there. We've got a lot of people who don't have their cell phones up. I just looked. Go put your phones up. If I see you with your phone, I give it to administration. I don't mess around. I just straight up give it to admin. So put your phone up, please. I used to do like put them away, but then that meant in a pocket, and then kids are always using them, and it's just annoying. Okay? So I put the little ones on the exponents so I know that it's going to be a linear equation because it always has exponents of 1. So when I look at A, B, C, and D here, is A linear, yes or no? We're answering the question, is it linear or nonlinear? So as we look at A right here, is that linear? It's x to what power? X to the first power, so yeah, it's linear, right? We could rewrite that equation like this. We could also rewrite that equation like this. Right? Those are all, it's the same equation written 3 different ways, and they're all linear. So yes, that is linear. How about B? Square root of 2x plus 3. Does anyone remember? So here's another flashcard moment because you're going to do this all year. If we have square root of x, what power is the x to? Like x to what power means square root? Anyone know that? It's kind of a weird thing. It's always the second root, and there's a 1 under here. So is it x squared or x to the 1/2? X to the 1/2. That means the same thing. So if it's cube root, it's x to the what? 1/3, right? 4th root, x to the 1/4, and so on, right? So the way I remember that is I envision this little part of the square root like a down arrow. So that helps me to remember that 2 is in the denominator. Remember, if you're not writing notes in 2 different colors, I will grade your notes and give you a bad grade if you don't write in 2 different colors. So if you need to go put your phone up here and grab a pen, go for it. I just want my pens back. The moral of the story. No, you don't like the color.
Is it okay if you highlight it instead of...
Yeah, highlight's totally fine. I honestly would have multiple colors and highlighters because sometimes I like to highlight, sometimes I like different colors, so it just kind of depends. But it's a system that's more relevant to you. You could highlight after, you don't have to highlight right now, but make sure you don't forget to highlight because otherwise you get bad grade on your homework, on your notes rather. I need to see color on every single page of your notes. I'm a stickler on that kind of stuff. Yeah, just grab another. We just need to write on them for a while. They'll probably go. All right. So does anyone remember what a square root graph looks like? You actually learned this freshman year in Algebra 1. It's been a while, I know. So if I do calculator, that's what it looks like. Right? So square root of x, if you have your graphing calculator out, you can hit y equals, which is in the upper left-hand corner. And to get square root, you go second x squared. So you can hit second x squared and then put 2x. Remember, x is right here next to alpha. So y equals is upper left. And then you hit second x squared. That gives you a square root. And then you hit 2x. X is right there. And then, I'll erase it so you can see how it works for mine. It depends on how old or new your calculator is, how it works. See how that cursor's still under the square root? Yep. Put your phone up and in that bottom drawer. So I have to hit the right arrow to get outside of that square root. And then I can put +3 like that. Okay? And then what it does is it takes a square root graph, which from your perspective looks like this. It just kind of arcs up and goes out to positive x values forever. And the +3 just takes that shape and moves it up 3 units. Right? When you add 3 to a function, it just moves it up. Subtract 3 to a function, it moves it down 3 units. Okay? So the graph looks like that. Yeah?
How do you put that x?
The x is right here next to alpha. So alpha is middle left. Anybody else need help? Ask if you need some help, right? And I'm happy to help you out. It's good to learn the calculator like crazy. Good job, Ronan. Thanks for helping. Appreciate it. Everyone else good? That one's fine. Yeah. That's old school, but it's good. It still totally works for everything we do in here. It's cheaper, that one. Are we good? Yeah? Okay. All right. So if this graph looks roughly like this, is that linear? No, it is not. It's not linear. Why? If I made you write a sentence why it is not linear, what would you say? Not a straight line. It curves, right? It curves is a sentence, right? You can make it short. It's better. How about C? Is it linear? No, it's not. Why isn't it linear? Because C changes directions, right? It looks like that. Yeah. So it goes up and then it goes down. So it is not linear. No. Because changes directions. I'm not writing a whole sentence. I might make you write one though. I'm working on your first test right now. Just so you know. I'm making it perfect. It'll be perfectly challenging. Math. All of these sections from Module 1. Okay? That's why the flashcards are super helpful, because you just study along the way, and then you got stuff memorized. D, linear? Yes, it's a straight line, right? Looks like a line, linear. Looks like a line. Okay. For E, graph those order pairs. Okay? Graph the order pairs. Try to draw a line, straight line that goes through all the order pairs. Pay attention to the fact that the graph goes by 40s on the y-axis. I'm going to show you on the graphing calculator too, because that's good to see. Yeah, draw the line. Oops. Oops. That's why. Why are you not showing the graph? I did not save that. There we go. Yep. Okay, so I'm just showing you the graph on this graphing calculator real quick. Once I figure it out. Let's just show this. We'll go like that. Okay. Oops. I still have it frozen. Okay, look at that. So those are the graphs graphed on the graphing calculator. You don't have to know how to do that, don't worry. It's a whole thing. It takes like a whole block period to teach you how to do this. So I'm going to do what's called a linear regression, which will draw the line through the points as close as it can possibly be. Again, you don't have to know how to do this yet, but we will be doing it eventually. You have to memorize every single one of these button pushes. Super fun. It's got perfect correlation, so it does hit the line exactly. Okay? So it draws that line exactly through the points. So is this linear or no? Yes, it is. It is linear. Okay? It was a long way to go to determine it's linear, but you know. Okay, an x-intercept is x-coordinate of a point where the graph crosses the x-axis. Next one's going to be the y-axis. You can just guess without even reading it. It's going to be like that, right? But read it and just double check. So this graph on the left here, this W-looking graph, that's a quartic function, by the way, if it looks like a W. It doesn't always look like a W, but sometimes it does. Depends what else is after the x to the fourth power. The graph appears to intersect. I'm going to draw in the intersection points at -3, -1, and +2. So the x-intercepts are just -3, -1, and +2. That's like what I like to call a duh question. Of course it is. Like, what else is it going to be? Right? Where does the graph intersect the y-axis? What's the order pair right here? Try again. What's the graph go up by?
0, 9.
What's the graph go up by? 4s, right? Each grid thing is 4, so it's 0, 12. Yeah, good. So don't, you guys, like, that's so annoying when I grade your tests if you don't think about the scale on the graph and you miss that question. So let's say you were a knucklehead and you said the order pair was 0, 9. How many points do you think I would take off if that was a 4-point question? I'm just waiting to hear guesses. I would probably take 2 off, right? Because you miss a pretty critical part, but you're also understanding it's greater than 8, and you wrote the order pair correctly, like x then y, right? So I'm going to take half the points off. Just so you can get a sense of how I grade, so that when you get your test back, it's not like a big surprise, the grades. Okay, and then the y-intercept is 12. Okay, so in between 16 and 8, right? 12. That's why. Okay, good old Ricardo launches a rocket from a balcony. The table shows the height of the rocket after each second of flight. So we want to identify x and y intercepts. So I'm going to write x intercept like this. So all I have to do is write the number down. I'm not writing it as an order pair. I'm just writing when x is 0, what's y? 15. When y is 0, what's x? Okay, 8, right? So that one is right here, right? And 0, 15 comes from right there. That's where like highlight's handy, right? Because you can quickly look and you know exactly where it came from. So what does that mean? What does 0, 15 mean? Where is he standing? In the description it says what he's standing on. A balcony. Right, so you launch it from the balcony. And then what does a 0 or 8-0 mean? Sorry. 8-0 means what? After 8 seconds, what happened? Is it back on the balcony? It's on the ground, right? Because the balcony is 15 feet up. So it's got to be back on the ground for it to have a height of 0. So you need to write something that says that. So launched from balcony, landed on ground. That's as short as you could do it. Launched. Sounds like he might burn his house down if he launches a rocket from his balcony, just saying. Launch from balcony. Landed on ground. So you'll have to describe what's happening because it makes you think about the math a little differently. And that's pretty short to have to write, right? Okay, next page. Talking about symmetry. So if I draw a dotted line that cuts this, what's that called, that U shape? Begins with a P. Parabola. Yes, good. So if I draw a dotted line, did I just cut the parabola in half? Right? Because I could take this side and fold it over and it would exactly match up. So if that is the case, what that is called is line symmetry. So it can be reflected in a vertical line. Anybody get messed up between vertical and horizontal? Like if you ever got mixed up, like which is left and right hand? I did as a kid. I would could never figure out what my right hand was. And then I figured out I'd throw with my right hand and I'm like, okay, that's it. And I'd sit there in elementary school and I'd be like, oh, that's my right. And I'd raise my right hand, right? Vertical, if you look at horizontal, you can see the horizon out there. It's about to start raining. You can look at the horizon out there. That's horizontal. So horizontal is this way, right? Vertical is up and down. In case you get mixed up with that. So this one has what's called is point symmetry. And if you rotate, so let's say I have point A up here. And we rotate it 180 degrees down to this point. If I do that time and time again, that's called A prime, A with a little apostrophe. If I do that time and time again, the function will exactly map itself out between the middle, like a point, right? So symmetry, when a figure is 180 degrees, goes in your next blank spot about a point and maps onto itself. So if I made another point here, B, then I'd have another point. That one was a little too low, but B prime right there. Okay, so that's what they call it, A prime, B prime. Just so you know. Okay, we're almost done. We only got A, B, C, D left. Then you get homework time. Okay, as I look at A, what kind of symmetry does it have? Line, point, or neither? No. Because if I draw a line through here, is it going to match up if I fold it over? Oh, hell no. Right? What does it have? Point. Oh, yeah. Right? Because if I rotate this 180 degrees, it's going to end up right there. A prime. That's a weird one, right? With the line, you wouldn't think it'd have point symmetry. I don't know. How about B? Line, right? Because I could draw that line right down the middle and fold it. So it has line symmetry. How about C? Neither. And then how about D? D looks just like that one right there. D looks just like that one, so it's got to be point, right? There's your homework. Okay, if you had trouble finding the homework on the textbook, get your computer out and I will help you find the homework on your textbook. I can show you up here too. I'm just going to